In this session, we are going to discuss solid of revolution and volume using washer method. The problem given here is the region bounded by the parabola y is equal to x square and the line y is equal to 2x in the first quadrant is revolved about the y-axis to generate a solid. Find the volume of the solid. Here, we are given a region bounded by a parabola y is equal to x square and the line y is equal to 2x in the first quadrant. This region is revolved about the y-axis. We get a solid. Now we are going to find the volume of this solid by using washer method. Shall we plot the given region? We first plot the parabola y is equal to x square. For this we substitute some x values, find the corresponding y values. Substitute x is equal to 0. What do we get? We get y is equal to 0. Substitute x is equal to 1. What is y value? Y is equal to 1. Substitute x is equal to 2. We get y is equal to 4. Plot these points 0, 0, 1, 1, 2, 4. Connect these points. This is the parabola y is equal to x square. Shall we plot the given line? Y is equal to 2x. We substitute some x values, find the corresponding y values. Substitute x is equal to 0. We get y is equal to 0. Substitute x is equal to 1. We get y is equal to 2. Substitute x is equal to 2. We get y is equal to 4. Shall we plot these points? 0, 0, 1, 2, 2, 4. Connect these points. This is the line y is equal to 2x. Shade the region between these two in the first quadrant. This region is revolved about the y-axis. This generates a solid. Now we are going to find the volume of this solid by using washer method. Look at this given solid. At each point y in the interval 0 to 4, we form cross sections by intersecting the solid with planes perpendicular to y-axis. Each cross section is of washer shape. Consider a particular slice. Now we are going to find the outer radius and inner radius of this slice. Look at the inner circle. The radius of the inner circle is from the y-axis to the line y is equal to 2x. On y-axis we have x is equal to 0. On the line y is equal to 2x we have x is equal to y by 2. So the radius is difference between these two. Y by 2 minus 0. That is y by 2. Shall we find the radius of the outer circle? What is the center of the outer circle? Center of the outer circle lies on the y-axis. There we have x is equal to 0. The circumference lies on the parabola y is equal to x square. There what is x value? X is equal to root y. So the distance between these two, root y minus 0. So the radius of the outer circle is root y. Outer radius capital R of y is equal to root y. Inner radius small r of y is equal to y by 2. Now we are going to find the limit of y. We start with first equation, y is equal to x square. From the second equation we have x is equal to y by 2. Substitute that in equation 1. We can write the right hand side as y square by 4. Denominator 4 can be taken to the opposite side. Then we bring y square to the left hand side. What is common now? Y is common. So we have y into y minus 4 is equal to 0. From this what do we get? We get y is equal to 0 and 4. Therefore the limit of y varies from 0 to 4. The area of the washer A of y is equal to pi into capital R of y the whole square minus small r of y the whole square. Substitute capital R of y value. minus small r of y value. We find LCM. Denominator 4 can be taken outside. So we have a of y is equal to pi by 4 into 4y minus y square. Shall we find the volume now? What is the formula to find the volume? The volume V is equal to integral a to b a of y into dy. What is the limit of y here? 0 to 4. Replace a of y value here. Shall we integrate this? Pi by 4 is a constant term that can be taken outside. Which formula we are using for integration? Integral x power n dx. Tell me the formula. Integral x power n dx is equal to x power n plus 1 divided by n plus 1. So in the first term, 4 is the coefficient. We keep that as it is. In the place of x we have y. Then what is n? N is equal to 1. So the integral of y is y square by 2 minus. In the second term, what is n value? N is equal to 2. So integral of y square is y cube by 3. Limit varies from 0 to 4. Substitute the upper limit 4 in the place of y minus lower limit 0 in the place of y. Simplify this. Volume is equal to 8 pi by 3 cubic units. Let us summarize. We sketch the given solid and a typical cross section. This is of a washer shape. Find the inner radius and outer radius of the typical cross section and we find the area A of y. We find the limit of y. Then we find the volume by using the formula V is equal to integral a to b a of y into dy.